we're going to take a look at what function notation is. And we're going to use function notation to help us evaluate functions by substitution and by using graphs drawn by hand or on the graphing calculator. And finally, we're going to use function notation to help us interpret functions that describe real-world data. So remember from chapter 4, every function defines a relationship between an input variable and an output variable. So function notation uses parentheses to name the input or independent variable for the function. For instance, when you see y equals f of x, it is read y equals f of x. And you can also say it as y is a function of x or y depends on x. So if someone said p equals f of x, how could we write that in function notation? So to write that in function notation, you would say you'd have p equals f parenthesis x parenthesis. And so you would read that p equals f of x. Another way that you could say the same thing is you could say p is a function of x. And you could also say p depends on x. Now, some functions represent equations. For example, the equation y equals 2x plus 4 represents a function. So we could rewrite y equals 2x plus 4. We could write that as f of x equals 2x plus 4. And if you see the notation f of 3 is telling you to substitute 3 in for x in the equation y equals 2x plus 4. So if you saw f of 3 would be equal to 2 times 3 plus 4, which would give you 6 plus 4, which would be 10. So what you would have is f of 3 equals 10. And so what that tells you is that the value of f of x when x is 3 is 10. Now the name, or by itself, if you just see f is the name of the function. Okay, so if I just say f and not f of x, I'm just naming the function. F of x is telling you that f is a function of x, or f depends on x. Now, not all functions are expressed as equations. You could have, for instance, this graph over here where we don't know the equation for the graph, but what we do know is that this graph represents a function, and that function is f of x. So you have no rule that's given, or no equation that's given, but you can still use function notation to find output values. So the way you do that is, let's take a look at what happens when x equals 4. So if you look at the graph of this function, when x is 4, the y value is positive 1. So what we see is that we can write the ordered pair as 4, 1. And so the value of x, the value of y when x is 4 is 1. And so what we're really asking when we see this expression, f of 4, is we're asking what is the y value when x equals 4. So you go to your graph, you find x equals 4, and you find out what y value that x value maps to. So if we check f of 2, we want to see, does f of 2 equal 4? So again, what is this asking? It's saying, what is the y value when x equals 2? We want to see, is it 4? So if you look at x equals 2 right here, if you go up to your graph, you'll see that the y value is in fact 4. So we would say that f of 2 equals 4. So if you look at this next question, it says, what is the value of f of 6? F of 6, here's 6. You go up to your graph, you see that that point f of 6 maps to 2. So you have f of 6 equals 2. Again, it's asking what is the y value when x is 6. Now, this next question is a little different. It says, can you find two x values for which f of x equals 1? So what this question really interprets or breaks down into is what x values have a y value of 1. And so the best way to do this is to take your pen and your pencil and to come up to your graph. And we want to know, when does this graph have a y value of x equals 1? So if you draw a horizontal line through this graph of this function, you'll see that the function f of x has a y value when x is 4 and a y value when x is approximately, say x is approximately 9.5. So when we look at this, we'd say the two x values are, so f of x, the y value is equal to 1 when x equals 4 and x is approximately 9.5. So in this investigation that we're going to look at, we're going to learn a little bit more about using function notation with graphs. So in this investigation, we're going to use this graph over here that shows a function, and we're going to use it to identify the mathematician who introduced functions. So the first thing you want to do is you want to describe we want to describe the domain and range of the function f in the graph. So if we look at this, we can see that this function, the domain is our x values. We can see that the domain is going to be equal to 0 included, and it's going to include all the x values up to 26 included. So 0 and 26 are both inclusive because you have those points on the graph. And then our range is going to be equal to, you'll see that the lowest y value is 0, the highest y value is 20. So our range is going to be 0 inclusive to 20 inclusive. So what we want to do now is we want to use this graph to find the value of each of these expressions or each of these notations over here in this table. And then after we do that, we want to complete the indicated operations. So f of 3. If we want to know what f of 3 is, then we would need to come up to our graph and we would need to find out what is the y value when x is equal to 3. So when x is equal to 3, we have 3 right here. It looks like f of 3 is going to be 5. So we have 5. F of 18. F of 18, again, remember it's asking what is the y value when x is 18. So you come to your graph and you find your x value of 18 right here, because notice it's counting by 2's. And then if you go up on your graph, you see that f of 18 maps to 16. So x maps to 16 plus f of 3 we said was 5. So 16 plus 5 is 21. So f of 18 plus f of 3 is equal to 21. Next, if we look at f of 5 occurs here. So f of 5 is going to be equal to 3. We have 3 times f of 4. F of 4 is equal to 4. So we have 3 times 4, which gives us 12. So f of 5 times f of 4 is equal to 12. Next, we have f of 15 divided by f of 6. If we look at our graph, again, f of 15 is going to be here. So f of 15 looks to be 10. So we have 10 divided by f of 6. F of 6 is 2. So we have 10 divided by 2, which is 5. And finally, we have f of 20 minus f of 10. So f of 20 is going to be 20. F of 10 is going to be 2. So we have we have 20 minus 2, which is equal to 18. Now, next we're going to take a look at some similar things, but we're going to have more than one operation involved in some of these. So it says, use the rules for our order of operations to evaluate the expressions at the right involving function values. Do any operations inside parentheses first, then use the graph to find the function value before doing the remaining operations. Write your answers in a table. So the first thing that we have is we have f of 0 plus f of 1 minus 3. So f of 0 is 8. F of 1 appears to be 7 minus 3. So we have 8 plus 7 minus 3. That would be equal to 12. So f of 0 plus f of 1 minus 3 is 12. Next, we have 5 times f of 9. So what we would need to find here is we would need to find the value of f of 9, which is what is the y value when x is 9. So f of 9 is going to be, it appears to be 1. And so we have 5 times 1, which is equal to 5. The next question is a little different. It says, find the x value when f of x is equal to 10. So again, it's asking, what is the x value when y equals 10? So the best thing to do is come up here to your graph, find where y equals 10 is, draw a horizontal line across your graph, and then we'll see that right here, we have y equals 10 when x is equal to 15. So we'd say x equals 15. The next expression is f of 9 plus 8, so that would be f of, again, you do your operations in parentheses first, so 9 plus 8 is going to be 17, so we're finding f of 17. F of 17, you go up to your graph, and 17 occurs right here. You see that 17, f of 17 is equal to 14. So we come back down here, we get 14. The next question is x when f of x equals 0. So x equals 0 occurs down here on the x-axis. So that occurs when your x value is 8. So we have x equals 8. Next, we have f of 8 times 3, so that would be f of 24 minus 5 times f of 11. Again, we have to find f of 24 and f of 11. F of 24 is 16. F of 11 is going to be 3. So we have 16 minus 5 times 3, which would come out to be 1. 16 minus 15 is 1. Next, we have f of 4 times 5, which would be 20. But then we have to subtract 1, so that's f of 19. And so we know f of 19 is 18. And finally, we have f of 12, which is just 4. So it goes on through here. It says, think of numbers 1 through 26 as the letters A through Z. Find the letters that match your answers in step 2 to learn the mathematician's last name. Find the letters that match your answers in step 3 to discover the first name. So you can go ahead and do that on your own. If you want to know his name comes out to be Leonard Euler. So he is the person who is responsible for helping discover functions and come up with this concept. So let's look at a few examples of how we can use function notation to evaluate functions and find values when the function is equal to a certain y value. It says you can use the function f of x equals 9/5 x plus 32 to find the temperature f of x in degrees Fahrenheit for any temperature x in degrees Celsius. Find the specified value. So we're going to look here. We don't have a graph to use now. We're going to just use our equation. It says f of 15. So to find f of 15, that means plug 15 in for x. So that would be 9/5 times 15 plus 32. And that would be equal to 9 times 3 is 27. 27 plus 52 is going to be 79. So we get 79. Oh, small mistake. I said 27 plus 52. It's going to be 27 plus 32, which is 59. So f of 15 equals 59. F of negative 10, again, we're going to plug negative 10 in. We have 9 over 5 times negative 10 plus 32. We're going to have 9 times negative 2, so that's negative 18 plus 32. We get positive 14. So again, f of negative 10 is equal to 14. Okay. Next question says, what is the x value when f of x equals 41? So this is, so f of x is 9/5 x plus 32. And we want to know what the x value is when that is equal to 41. So we would subtract 32 from both sides. That would give us 9/5 x equals 41 minus 32 is going to be 9. And then we're going to multiply by the reciprocal, which is 5/9. And so we get x is equal to 5. So when the function is equal to 41, then x is equal to 5. And the next one says, what is x when f of x is equal to negative 4? So we have 9/5 x plus 32 equals negative 4. We have 9/5 x equals negative 36 after we subtract 32. And then we're going to multiply by our reciprocal of 5/9. And that's going to give us x equals negative 20. So again, when f of x is equal to negative 4, we know that x is negative 20. And what does that mean if you were to look at the graph? That would mean that the coordinate negative 20, comma, negative 4, that point is on your graph. Okay. The next example says, given f of x equals 4x plus 7 and g of x equals 7 divided by x minus 1, find f of 3 plus g of 3. So in order to do this, we need to know what f of 3 is, and then we need to find g of 3. So f of 3 represents 4 times 3 plus 7, which is going to be 12 plus 7, which is 19. And g of 3 is equal to 7 divided by 3 minus 1, which is 7 over 2. So if we add that, we would have f of 3 plus g of 3 is equal to 19 plus 7 over 2, which is just equal to, that's 3.5, so 22.5. Alright. And so finally, we can also use function notation to describe points on a graph. It says, use the graph of f of x to determine f of 3. So to figure out what f of 3 is, f of 3, you go to your graph right here and you see that when x is 3, y is 1. So f of 3 is equal to 1. And again, what does this really mean in terms of the graph? This means that the ordered pair, so this means the ordered pair uh, 3, 1 is on the graph of f of x. It shows up, that point is right there on the line, which represents the graph of f of x. Next, it says x when f of x equals 4. Again, this is asking, what is the x value when y equals 4? So you go to your graph. Y equals 4 is right here. You see that it crosses right there, and so that corresponds with the x value of x equals 5. So x equals 5 when y equals 4, and this gives us the ordered pair 5, 4, telling us that it is on the graph. Now, one thing to make note of, since we saw f and g in here, we don't always have to use f for the name of the function, and the input doesn't always have to be x. You'll notice in our next lesson in chapter 8 that we're going to see instead of x, we'll see t. Instead of f, we'll see h. And a lot of times you can choose the letters. You can choose whatever letter you want to represent the name of the function or the variable. But a lot of times when you're dealing with functions that represent, for instance, height, you'll say h. Or if you're talking about your independent variable as time, you would use t. But you do have to remember that when you use a calculator, you're going to have to use x and y, unless Desmos will let you use some other letters as well. So to quickly summarize, what are the independent and dependent variables if u equals f of t? And so again, what this is saying is u is a function of t, so u would be the dependent variable, and t would be the independent variable. Okay. It says if g of a equals 2 minus 3a, what would you do to find g of negative 1? G of negative 1 would mean that you plug in negative 1 in for the letter a. So you have 2 plus 3, which is 5. And then finally, what's being multiplied in f of x equals negative 2x plus 5. You're multiplying the negative 2 times x. You're not multiplying the f and the x. Okay. So looking at this, if you wanted to find f of 0, you would have 3 times 1 plus 0.5 to the 0 power. F of 1 would be 3 times 1 plus 0.5 to the first power. F of 2 would be 3 times 1 plus 0.5 to the second power. You type those into your calculator and they will tell you what f of x is. In example 2 is a little bit different. Okay, it says f of x is 3x. And then it asks what is f of x minus 1 and what is f of 2x plus 5. So when you see this, you have to remember that whatever's inside these parentheses, you're plugging in for x. Plug in for x. Okay, so if f of x equals 3 times x, then f of x minus 1 would be equal to 3 times x minus 1. And so you can distribute that and get 3x minus 3. And then if you had f of 2x plus 5, you would have 3 times 2x plus 5. Distribute that, and you have 6x plus 15. So again, it doesn't matter what you see in the parentheses. Whatever you see there, you plug it in for each x that shows up in your equation. So go ahead and begin working on the homework. If you have any questions, message me on Remind, email me, or feel free to ask questions the next day in class.